Picture this. Priya runs analytics for a fintech and she has a table with 2 million customer reviews. Her boss wants sentiment scores by Friday. The old answer was a Python job, an external API, and a week of plumbing. Watch what happens instead. She writes one line of SQL, runs an LLM right on that table, and the data never leaves Snowflake. That is Cortex. Sentiment summaries, classification embeddings, all as functions you call in plain SQL. Today you will learn when to use Cortex, when to reach for an external model like Claude, and how to combine the two. Here is the big idea, and it is simpler than you think. Cortex exposes LLM and machine learning power as built-in SQL functions. That means you call AI right inside a select statement against your own governed tables. There is no pipeline to ship rows out to an external API and then ship the results back in. Think about how much that removes. No export job, no network hop, no glue code holding it together. The AI comes to your data instead of your data going to the AI. That one inversion changes everything about how you build. So why does this actually matter in production? Three reasons. First, no data egress. Your sensitive rows stay inside Snowflake security boundary the entire time. Second, no extra infrastructure. There is no API gateway to run. No batch export job to babysit at 2 am. And third, the one I love most. It is just SQL. That means your analysts can use AI directly, not only your machine learning engineers. You just took a capability that lived in one team and handed it to everybody who can write a select. Take a look at the Cortex function families because there are more than people expect. First, the task functions, sentiment, summarize, translate, extract, answer, and classify. These do one focused job each. Then the generative one, complete, which runs a model you choose against any prompt you give it. Next, vectors, embed your text, then run vector search over it, and the higher level apps, Cortex Search and Cortex Analyst. One honest caution: availability and the model list change fast. So always check the current docs before you commit. Now let us actually write there is sentiment and summaries in a single query. The first one selects a review ID and runs Cortex sentiment on the review text, returning a score per row. The second runs Cortex summarize across long documents. Read the intent, not the syntax. You just bulk enriched thousands of rows with one statement. No Python, no export, no second system. One important note for today: the older Snowflake.cortex name, space still works but is being deprecated. The new canonical forms are AII complete and AII classify, so prefer those going forward. Let us route some real support tickets. This query selects the ticket ID, then calls Cortex complete with a model name and a prompt. The prompt says classify as billing bug or other and then glues on the ticket body. That is it. One call categorizes every ticket in the table. No training run, no label dataset, no export, just a sentence of instruction and your column data. One thing to flag: the model name shown is a placeholder and the available models change over time. So verify what is actually live in your account. Complete is the workhorse. So let us sit with it a moment longer. Same shape as before. You pass a model a plain English instruction and then concatenate your column. But classification is only one use. You can extract fields, draft replies, or summarize all from the same function. The pattern is always the same: a prompt plus your data equals an answer per row. And you pick the model deliberately, trading cost against quality for the job at hand. As always, model availability shifts, so confirm what is live before you ship. Now the question everyone asks: Cortex or an external model like Claude? Here is the honest split. Cortex is your choice for bulk enrichment on governed warehouse data in SQL with no egress. External Claude through the API or Cloud Code is your choice for complex agentic workflows, code generation, the very latest models and custom tools. So do not think of them as rivals. They are complements doing different jobs. The real question is never which one is better. It is, where does the work actually live? Let us make the Cortex case concrete. Three signals tell you Cortex wins. First, you need to enrich millions of rows that already live in Snowflake with sentiment classification or summaries. Second, governance and data residency matter, and the data simply must not leave the boundary. That is a compliance answer, not a preference. And third, you want your analysts using AYI in SQL without anyone standing up new infrastructure. When you see those three, you are not even choosing. Cortex is the obvious move. Now the other side, when does external Claude win? First, when you are building the pipelines themselves, the actual SQL and PSpark. That was the whole workflow from the previous video. Second, when you need complex multi-step reasoning, tool use or agentic automation that goes well beyond a single function call. And third, when you need the very newest model or a capability that is simply not in Cortex yet. Notice the pattern. Cortex operates on the data. Claude builds the thing that operates. So here is where it gets powerful. You combine them, you use Claude external or through Claude code to build the pipeline and write the prompts. Then you use Cortex to run that AI enrichment at scale, right inside the pipeline where the data lives. Let that land for a second. Claude engineers the system. Cortex operates on the data. You get the smartest model for the hard design work and the cheapest, closest execution for the millions of rows. That is not a compromise, that is using each tool for exactly what it is best at. Let me name the two higher level labs quickly so your picture is complete. Cortex Search gives you semantic retrieval over your own text, finding by meaning, not just keywords. Cortex Analyst turns plain natural language into SQL so a business user can ask a question and get a query. Both build on the same core idea you have seen all lesson, AI where the data lives. But here is my honest advice. This area moves fast. Know that these exist and verify their current behavior in the docs before you design around them. Let us tie it together with one real worked example. This statement creates a new table called tickets enriched. It selects everything from the raw tickets table and adds two columns. One runs Cortex sentiment on the body, the other runs Cortex summarize read what just happened. One statement turned raw, messy tickets into a sentiments code, summarize table. Now your dashboards and your routing logic run on AI enriched data with no export and no extra service. And again, prefer the new AI complete and AI classify forms over the older deprecated namespace. Now let me show you the trap. Because I have watched teams fall into it, the anti-pattern is this. You build a whole export job to ship rows out to an external AP. I just to score sentiment. Why does that break? You pay egress cost, you maintain a fragile pipeline, and your data leaves your boundary for no good reason. Here is the rule. If the data is already in Snowflake and the task is standard, do it with Cortex. Do not build a bridge to cross a river that is already under your feet. But let us be grown-ups about cost, because Cortex is not magic. These calls consume credits and tokens. Running an LLM across millions of rows is not free. So batch sensibly, enrich incrementally, scoring only the new rows instead of reprocessing the whole table every single run. And treat the spend like any other compute. Measure it, watch it, and only enrich the rows you will actually use downstream. The engineers who get burned are the ones who score everything every night forever. Do not be that team. So let us turn that cost lesson into a real pattern. The rule is, do not rescore the whole table nightly. Enrich incrementally instead. You put a stream on the source table to capture what changed, and a task that runs Cortex only on those new or changed rows. If this feels familiar, it should. It is the exact same pattern as any good pipeline. You process the delta, not the world. The I function is new, but the discipline of touching only what changed is the oldest rule in data engineering. Now the win that makes security teams smile, governance with the in-database path, your data, your prompts and your results all stay inside Snowflake's existing security and access controls. That means there is no new vendor to risk assess for this enrichment work. And for regulated data, you get the simplest, most powerful sentence in the room. It never left. I have sat in audit meetings where that one phrase ended a 45-minute debate. When the data never crosses the boundary, half the hard questions just disappear. So here is your decision card, the one to screenshot in warehouse bulk. Governed enrichment goes to Cortex because it is just SQL. Build work, code generation, complex reasoning agents, or the newest model goes to external Claude. And real systems, they use both. Claude builds it, Cortex runs the AI on the data. Keep this split in your head and you will rarely choose wrong. One footer note, as always, verify the exact Cortex function availability in the current docs. A quick honest word about staying current. Cortex adds functions, models and regions quickly. What is generally available today may have been just a preview last quarter. So always confirm three things in the live docs: the function names, the model options and the regional availability. But here is the reassuring part. The decision logic you learn today is stable, even as the specific functions evolve. Names will change. The question of where the work lives will not. So let us bring it home. Today you saw that Cortex brings AI directly to your governed data, while Claude builds the systems around it. You learned the function families, the Cortex versus external split, the combined pattern, and the cost and governance reality behind it. If you want to go deeper, watch Claude for Data Engineers linked below for the full AI in data engineering workflow, and subscribe because the Databricks and Fabric AI videos are coming next. One last thing, what would you enrich first? Drop it in the comments. I read everyone